Ignition sequence starts.
The International Space Station's Flight Control Room, where specialists are monitoring the systems on the station and working with the Expedition 59 crew members, 3 of whom are just 10 days away from wrapping up a mission of more than 200 days in space. Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques will be turning more of their attention to preparing to return to Earth in a week and a half, while the whole crew continues with the station mission of scientific research in orbit.
Welcome to Space to Ground. I'm Isidro Reyna. This week, science and commercialization of the International Space Station. Future long-duration missions face significant challenges maintaining crew health. A critical area is supplying adequate nutrition, as certain vitamins and nutrients in supplied foods have been shown to degrade extensively during extended storage. This week, the crew worked on the bionutrients experiment. Bionutrients demonstrates a technology that enables on-demand production of human nutrients during long-duration space missions. The process uses engineered microbes like yeast to generate potential supplements for food that may lose these nutrients over time. Samples are frozen for eventual return to Earth for analysis. This approach may also benefit on-demand production of vitamins and other biomolecules in remote areas on Earth. NASA is opening the International Space Station for commercial business to accelerate a commercial economy in space. NASA will continue research and testing in low Earth orbit to inform its lunar exploration plans, while also working with the private sector to test technologies, train astronauts, and strengthen the burgeoning space economy. Providing expanded opportunities at the International Space Station to manufacture, market, and promote commercial products and services will help catalyze and expand space exploration markets for many businesses. NASA also is enabling private astronaut missions of up to 30 days on the International Space Station to perform duties that fall into the approved commercial and marketing activities outlined in the directive, with the first mission as early as 2020. In the long term, NASA's goal is to become one of many customers purchasing services from independent, commercial, and free-flying habitable destinations in low Earth orbit. Head to nasa.gov, where you can learn everything there is to know about commercial and marketing activities aboard the space station. And if you have an activity you'd like to suggest as a U.S. entity, you can find out where to send those proposals. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Promoting commercialization of space research is one goal of the International Space Station. Doing scientific research is another. Research such as learning how the microgravity environment impacts the human body, as well as other experiments in areas like physics and biology that take advantage of the weightless environment. For example, an experiment in which a device about the size of a thumb drive, which contains human cells in a 3D matrix, may help scientists learn how the cells respond to stresses, drugs, and genetic changes. These devices are known as tissue chips. The International Space Station is designed to be a laboratory in orbit that can benefit people on Earth and teach humankind what we need to know to explore beyond Earth orbit in the years to come, including returning to the Moon in just a few years. A couple of recent experiments have built on both of those aspects.
Cementing our place in space. Presented by Science at NASA. As your dog drags you around the block for his morning walk, you're probably not thinking about the wonders of the neighborhood sidewalk. But that concrete is pretty great. Next to water, it's the most widely used material on Earth. In the future, concrete may be equally useful off the planet, when humans construct a permanent base on the Moon. They'll need sturdy stuff that can weather bombardments from solar radiation and meteorites. No one wants a crack in their moon base. The key to making out-of-this-world concrete may be to study it out of this world. 2 experiments have taken place aboard the International Space Station, or ISS, to do just that. The Microgravity Investigation of Cement Solidification, or MIX, and Multi-Use Variable G Processing Facility, or MVP Cell 05. Researchers from Pennsylvania State University and NASA's Marshall Space Flight Center are analyzing the study's results. Concrete is a mixture of sand, gravel, and rocks glued together by cement paste made of water and cement powder. And it's not as mundane as it looks. Under the surface, it's quite complex. What goes on there is key to its strength and durability. Yet scientists still don't understand all the details of concrete's chemistry and microscopic structure. Processing methods aren't cast in stone. There's plenty of room for improvement. Alexandra Redlinska, principal investigator for both experiments, says, "Our experiments are focused on the cement paste that holds the concrete mixture together. We want to know what grows inside cement-based concrete when there is no gravity-driven phenomenon, such as sedimentation. It all begins when water is added to the cement. To put it very simply, the cement's molecular structure changes when the cement grains dissolve. Redlinska explains, as the old molecules dissolve, calcium silicate hydrate and calcium hydroxide start to crystallize. Myriads of these tiny crystals form all through the mixture, interlocking with one another and with the other concrete ingredients, such as gravel. The ISS experiments are researching how this all plays out in space. Redlinska says it could change the distribution of the crystalline microstructure and ultimately the material properties. The ratio of the water-cement powder is critical to making the concrete components combine effectively and determining the strength and durability of the final concrete. Will this ratio need to be different on the Moon, where gravity is about 1/6 of Earth's? That's the kind of question the experiment will shed light on. For the MIX experiment, astronauts added water to a series of packets containing dry cement powder, then added alcohol to some of the packets to stop the hydration process at specified times. For MVP Cell 05, astronauts also hydrated dry cement, but for this experiment, they used a centrifuge on board the ISS to simulate gravity at a number of strengths, including lunar gravity and Martian gravity. For both experiments, the samples were returned to Earth for analysis. We're already seeing and documenting unexpected results, says Marshall's Richard Grugel, co-principal investigator for MVP Cell 05. Redlinska adds, what we find could lead to improvements in concrete both in space and on Earth. Since cement is used extensively around the world, even a small improvement could have a tremendous impact. We might even end up with better sidewalks for walking our dogs. For more from the International Space Station, go to www.nasa.gov/ISS-science. For information about other weighty matters, visit science.nasa.gov.
Along with hands-on work with science experiments and spacewalks and visiting vehicles, International Space Station crew members use some of their time for educational events in which they talk about science with students on Earth, discussing their mission, sharing the value of learning about science, technology, engineering, and math. Explaining STEM topics to students is an important part of the station's education mission. In this demonstration video, Randy Bresnik demonstrates Newton's second law of motion.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Jolly good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small, something you might have at home, a little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. And let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration is faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
Demonstrations, like the one we just saw, are a high-profile way that astronauts in space can connect with people on Earth and share the experience. But some have found other ways to connect their time in space to life on the planet. One station crew member, who was watching a natural disaster unfold on Earth right below him, found a way to help.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain, and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, Maria took up a big chunk of what we could see. It was going to cover the entire island. After the hurricane, their power grid was pretty much taken out. You just couldn't see the island anymore. The hurricane, I think, had a huge impact on, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conferences. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear. How do you compare?
What is the most impressive view?
How did Puerto Rico look?
Are astronauts allowed to visit?
How often? What is the minimum number of?
It was awesome because, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to get out and kind of come full circle with those students, to go and see them in person and, kind of reiterate how important they are and just to give them a little bit more hope because there's still a long way to go on the island.
He's a hero for us. Kids love him and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
No one knows the International Space Station better than the people who live and work there, and they often take time to show off their home on orbit. During Expedition 52, the crew members produced a series of bite-sized explanations of station components, which they called Speedy Time, for reasons that'll soon be clear. Here, flight engineer Jack Fisher gives us a quick but thorough tour of payload activities inside and outside the airlock in the station's Japanese laboratory module, Kibo.
Hi, everybody. I'm going to do my best over the next few months to show you in bite-sized chunks this wonderful place I get to call home. I'm going to have to talk fast, so we're going to call it Speedy Time. All right, the first one is the gem airlock. This is so cool. It has a slide table. We open it up, the slide table comes out, we can put all sorts of things on it, put it back in, depressurize it, because it's an airlock, and then slide it outside. We have a robotic arm. We can control it with this wonderful panel here, or they can control it from the ground. How cool. And then, once it's outside, we put all sorts of experiments out there. Let's take a look, because it's gorgeous. This is the gem window. Woo! And there are some of the experiments, including the robotic arm, which then controls all of those experiments once they're outside and puts them in the right position. Or, in the case of small satellites, it actually launches them. How cool is that? That is your first Speedy Time video. Have a great day. See you next time.
One goal of International Space Station science is to figure out the impacts of the space environment on the people who spend extended periods of time there. And that'll be the case for the crews on future missions that go out away from Earth. One of the hazards confronting those crews will be the radiation that those men and women will encounter on the trip. NASA's Human Research Program has been looking into several ways to try to shield astronauts from galactic cosmic radiation.
Just as early explorers had to endure weather as they traveled to new lands and explored new areas, astronauts, when they go on space travel outside the Earth's magnetic field, will have to endure space weather. This space weather would include things like galactic cosmic rays, which are remnants from supernova, and also solar storms, which include things like solar particle events and coronal mass ejections. So as astronauts are traveling to Mars, they're going to be enduring the space weather, and it's harmful to the body in a couple different ways. There's an in-flight risk from things like solar storms, and those really present acute radiation sickness type issues that would have to be dealt with operationally in real time. And then there's also long-term late effects like cancer, cardiovascular disease, and possible central nervous system effects. And those are more possibly late-term effects that would come into play after the mission. So just like the early explorers, NASA's mission is to bring all of the astronauts home safely. And to do that, we're investing and looking into these shield design strategies that include ways that mitigate exposure from all forms of space weather. So we look at habitat design and overall vehicle optimization to reduce the in-flight risk from solar storms. But then we're also looking at material design and other vehicle optimization strategies to reduce the risk from long-term exposure to galactic cosmic rays.
A good portion of the research being done on the International Space Station is designed to support future missions that will go out beyond Earth, to the Moon and Mars and out into the solar system. The people responsible for those projects are heroes, just like the astronauts who get to go to space.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
NASA's Orion program is developing the vehicles that will take humans out into the solar system. SpaceX and Boeing are building ships to take crews to the International Space Station, where we'll learn how to live in space on those future missions. Here's a feature that'll help us all see what those future missions of discovery will look like as America turns an inquiring eye out into the solar system.
From the Kennedy Space Center in Florida at T-minus 3 hours and holding.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
Not only for our expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Crew ingress and work at this time.
See that. Flight crew O2C, close and lock your visors and initiate O2 flow.
T-minus 10, 9, 8, 7, 6. All the engines up and burning. 2, 1, 0, and lift off.
The dawn of Orion and a new era of American space exploration.
Now, if you would like to get another look at any of the stories that we feature today, and frankly, why wouldn't you, right? Well, you can. Check us out on YouTube and Facebook at the addresses that are magically appearing right there on your NASA TV screen. And while you're there at either of those places, be sure to take a few minutes and look around, because you will find a lot of excellent stuff about NASA and America's human spaceflight program. And while you're out there on the internet, also check out Houston, We Have a Podcast. That's us talking with folks all over NASA about their work in all aspects of space exploration. Our new episodes post every Friday, and today, being Friday, today's episode is where we get the inside story on the restoration to what it looked like 50 years ago of the flight control room here in Houston, actually one floor directly over my head right now, from where the Apollo moon landing missions were controlled. Excellent story. It'd be worth a listen. Go to nasa.gov/podcasts for today's episode. It's the same place you go for all of our episodes and the full library of all NASA podcasts. And you can also get all of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.
Good with FTC, took all the way out. I was able to open them only by 30 degrees or so.
Good copies. Понял, принято. Тоже донесем до специалистов.
Copy, I'll let the specialists know.
Согласен, не самое.
In February, I had an